All right, let's get right into it. Today, we're looking at a fascinating mathematical demonstration that completely flips the script on how we think about physics. Now, this isn't another theory. Instead, think of it as a rigorous, self-contained grammar for reality, one that starts with the whole field, not the tiny little parts.
Okay, so let's break down the core shift in perspective here. On the left, you've got the standard way of doing things, the particle primary approach. It's kind of like trying to build a car by just finding random parts and then trying to figure out how they all bolt together. You end up needing a lot of extra screws and glue to make it work. But on the right, we have a field primary approach. This starts with the complete, perfect blueprint of the car, what it calls global closure, and then demonstrates how every single part, every nut and bolt, is just a necessary consequence of that one unified design. So here's how we're going to walk through this. First, we'll establish what we mean by a new grammar for physics. Then we'll dive right down to the very bottom, to Tier 1, the origin point of everything. Now, stick with me here, because we're going to do something a little different and jump straight to Tier 3. Why? Because we need to understand how we measure things before we can understand what we're measuring. Once that's clear, we'll circle back to Tier 2 to see how geometry itself is born. And finally, we'll tie it all together with the scaling law and see how the whole system achieves perfect closure. Right, first section. What on earth do we mean by a new grammar? This is so important. We're not talking about a theory that needs to be tested against other theories. This is presented as a fundamental set of rules, like the grammar of a language. It doesn't describe one possible story, it describes the rules by which any story can be told, or how anything can persist in reality at all. And that leads us to this really fascinating idea, an interjective empirical derivation. Let's unpack that. The term interjective is used because the entire system is self-referential. It only talks about itself. Think of a perfect circle. You can't stand outside of it to observe it, because your observation point isn't part of the circle's definition. This grammar demonstrates that reality is like that circle, a single closed loop. There's no separate you looking at an it. The system either is or it isn't. You either recognize its closure or you don't. The subject-object split just dissolves. So where does a system like this even start? Well, we have to go all the way down to the foundation, to Tier 1, and this is where things get really wild. We are talking about a starting point that exists before space, before geometry, before any dimensions we know. It's the pure, undifferentiated ground state of being. This origin point has a name, the addressability substrate. The key word to focus on here is addressability. Imagine a completely blank infinite canvas of pure potential. Nothing's there yet. But what if one point on that canvas could somehow refer to or address itself? That one simple act of self-reference, of self-interaction, is the spark that kicks the entire universe into motion. It's the very first rule in the grammar book of reality. And believe it or not, this entire complex architecture is generated from this one single expression. Now, don't think of this like a typical math equation. It's more like a fundamental command or a principle of persistence. It states that the field, Q star, must perpetually persist by recursively finding and referencing itself. It's like a snake constantly biting its own tail, not out of hunger, but to confirm its own existence. This is the engine that drives everything. So what happens when you apply that one simple rule over and over and over? Well, you might expect chaos, but instead, it naturally unfolds into this beautiful, ordered, 9-cell pattern. You can think of it kind of like music. You have a way to start a process, initiation, a way to change it, modulation, and a way to resolve it, stabilization. When those three principles interact with each other, you get this precise 3x3 grid. This table isn't arbitrary. It's the archetypal blueprint for all the dynamics of the field that follow. Okay, now for our jump to Tier 3. And this is a really deliberate move. The architecture insists that before we even try to derive the physical world, we first have to understand the tool we're using to look at it, our own process of measurement. This is crucial because it stops us from confusing the map with the actual territory.
This grammar brings us face to face with one of the biggest questions in modern physics. For nearly a century, the mainstream answer has pretty much been, yep, it seems to be. But this demonstration offers a radically different answer.
And the answer this demonstration gives, it's crystal clear. The underlying field is completely deterministic. All that randomness we think we see in quantum mechanics, it's not a feature of reality. It's an artifact created by our instruments. It's a shadow, not the object itself. So you have to be asking, how can that be? Well, it's explained with this concept, statistical compression. Imagine you're listening to an incredibly complex symphony. Our scientific instruments are like a microphone that can only measure one thing, the volume, or the magnitude. It's completely deaf to the melody, the harmony, the rhythm, the tempo, all that rich phase information. By only recording the volume, you've completely lost the song. All you have left is a statistical mess of loud and soft moments. Probability, in this view, isn't real. It's just a mathematical measure of all the information our instruments are throwing away. And once you grasp that, the biggest mysteries of quantum mechanics start to look very different. That whole weird quantum collapse? This demonstration frames it as just a filtering process. Field patterns that can't maintain their recursive closure, that aren't admissible, they just fizzle out. And particles? They're not these fundamental little billiard balls. They're just what we happen to see when our limited instruments take a high-resolution, coherent field and compress it down into a blurry, pixelated dot. Okay, so now that we've established the foundation in Tier 1, and, just as importantly, we've clarified the illusions of measurement in Tier 3, we can finally come back to Tier 2 and see how the physical world we know, the world of space and geometry, is actually derived. This is probably one of the biggest takeaways. In this grammar, space isn't some empty box that the universe happens inside of. No, geometry itself is an expression of the field. It's the visible geometric signature left behind by the field's own act of closing in on itself. Here's how that plays out. This table might look a bit intimidating, but the idea is actually quite elegant. The same fundamental act of field closure projects itself in two ways that we can perceive. One projection gives us the formative forces we measure, like electromagnetism. The other conjugate projection gives us the containing geometry we inhabit, the polyhedral shapes. A force and a shape aren't two different things. They're two sides of the exact same coin, the same single act of closure. And this leads to a pretty stunning conclusion. For decades, physics has been on the hunt for the graviton, a hypothetical particle that's supposed to carry the force of gravity. Well, this demonstration shows that if geometry is just a direct expression of the electromagnetic field, then you don't need a separate particle for gravity. It's not a force that travels through space, it's a property of space itself, responding instantly to the field. All right, let's bring it all home. How does this entire system lock itself down and prove its own consistency? It does so through a scaling law that works seamlessly from the tiniest scales all the way up to the cosmic. It's all held together by this beautiful idea, the recursive scaling law. The best way to think about it is like a set of Russian nesting dolls. You can't have a stable molecule until you first have a stable closed atom. The perfect closure of the atom becomes the container, the substrate, for the next level up, the molecule. The closure of molecules then becomes the substrate for a cell, and so on. Each layer of reality can only form once the layer beneath it has achieved its own perfect stable closure. The exact same principle scales all the way up. And get this, it even redefines what we think of as energy. In this grammar, energy isn't some fundamental substance, it's simply what you get when there's an error, a failure. It's the cost of incoherence, the noise and heat that gets radiated away when some part of the field fails to close perfectly on itself. A coherent system is quiet and stable. An incoherent one is what we measure as energy. And here's the final mic drop. To prove its total closure, the system doesn't need us to measure constants in a lab and plug them in. No. Fundamental constants, like the gravitational constant g, are derived from the internal properties of the field itself. It's the difference between jamming a puzzle piece into place versus discovering that the shape of the piece was determined by the puzzle itself all along. It just falls right out of the math. And so the final statement of the entire demonstration says it all. It is a complete, self-referential, and fully self-consistent architecture. Everything we see at every scale is shown to be just an expression of one single, unbroken, recursive process. The recursion holds. So we'll leave you with this to think about. What does it really mean for us, for our place in the universe, if the very space we move through is not an empty stage for action, but is instead the visible geometric signature of a single, unified, and intelligent field?